Hi, I'm Meta Spencer, and today we're going to talk some more about clouds. I just can't get enough of conversations about clouds, especially white clouds made up of little tiny particles, aerosols. And so today we're going to talk about it again, and you should be as interested in it as I am, because this may be one of the things that can help save our planet one of these days. If all else fails, or maybe even if some other things don't fail, let's hope. I've got three people here who know about something called marine cloud brightening. Of course, they're not really here. They're scattered all over the world, but we're going to have a conversation about the subject, and they all know something about it. I think, San Diego is Jessica Wan, whom I saw yesterday giving a talk about her PhD thesis. She models things. She makes models of oceanographic phenomena, including marine cloud brightening, which we can review in a moment. And so she gave a talk about it. And one of the people who was there officially to question her was Robert Tulip, who is let's call him a climatologist for want of another term at the moment, because he certainly is on the steering committee of the Healthy Planet Action Coalition. Is that what it stands for, Robbie? Yeah, okay. The Healthy Planet Action Coalition, which has a whole bunch of activities going on all the time, including at least once a week, there's some kind of webinar talking about ways in which we may be able to chill the Arctic, cool it off again. And that is certainly number one priority, or it should be. And in Seattle is Patricia Quinn. Patricia is at the National Oceanographic and Atmospheric, what's the third word?
Administration.
So short for NOAA. It's a big organization that's trying to work on the atmosphere and climate. I'd like to start with Patricia, since in fact you are a longer term scientist working on these issues, and I don't really know anything about your work. Good.
So I have worked for NOAA for a little over 30 years. And my research group's main goal is to go out on ships and measure atmospheric particulates and how they influence climate and air quality. So we've been in all of the world's oceans. We've been in clean marine backgrounds where there's not very many influences from the continents. And we've also deliberately been directly downwind of continents so we can see what kind of particles are emitted, like dust, for example, from deserts, or sulfates come from coal-powered plants. So it's just looking at the whole range and the complexity of atmospheric particles over the oceans. And this goes from clean remote marine, which is mainly sea salt and sulfate that comes from phytoplankton in the ocean, to very polluted regions like the Houston Ship Channel, where it's just an awful place to be and there's a lot of industrial pollution.
Now, let me make sure I understood you a minute ago. We're talking about aerosols, which are particles, tiny particles that are in the air. Everything counts as an aerosol unless it's water, as I've been told. Anyway, but did I hear you say that sulfates come from plants?
No. Coal-fired power plants.
Oh,
that's the anthropogen. That's the human source of sulfate, but it also is derived from phytoplankton in the ocean, because phytoplankton emits a compound that once it gets into the atmosphere, it gets oxidized and turned into sulfate.
Now, there's something, I see the initial starts with a D, 4 letters, an acronym that comes from phytoplankton. Tell me whether I'm thinking of the same thing you're referring to.
Yes, it's the exact same thing. It's DMSP comes out of the phytoplankton, and then it gets converted to just dimethyl sulfide, or DMS, and then that gets emitted to the atmosphere and gets oxidized to sulfate.
Okay, and that's good. We
That's
don't,
good.
it's not something we want to worry about. It's something that we actually need and that goes on and has always happened, right?
Correct.
Yeah. So we're not worrying about sulfur now at the moment. There are people
Well,
who
the interesting thing is that as we clean up power plants to
Mhm.
try to reduce the amount of sulfate particles in the atmosphere, those sulfate particles are actually reflective. So they are reflecting sunlight back to space. So that's less heat that's heating the surface. So as we clean up power plants and decrease the amount of sulfate, we're adding to the warming in the atmosphere.
Mhm. Well, I'd heard that the main worrisome part of the change is the reduction of sulfates from ships' fuel.
That's true also.
Mhm.
There's been this mandate to reduce the amount of sulfur in
Mhm.
fuels. Yeah.
And so is that in your opinion, the main reason or a main reason for the recent upsurge of global temperature?
I don't think so. I don't think it's just not that big of a source compared to
I
other
see.
sources of sulfur. Yeah. I think
So
it's more the power cleaning up the power plants that's had a bigger impact. That's
okay.
my understanding of it.
Uh-huh. All right. Well, okay. So that gives me a sense of what you're spending your time doing. Very good. Thank you. Now, Jessica, why don't you, I don't know how you're going to encapsulate all of yesterday's presentation, but you can give us sort of a thumbnail of what you have been doing, modeling the effects of what we have called marine cloud brightening. That is the notion that white clouds reflect more incoming sunshine back out to space than dark clouds. Anything white reflects more than dark things. And so we want a lot of white clouds. And to make white clouds, you get little tiny, tiny, tiny particles of various sulfate aerosols, which usually so far has been seawater, the salt in spray from the ocean, and spray it and get it up into the clouds. And if a cloud is a little gray, it'll whiten it a little bit. And that's all we need to do is whiten the clouds a little bit, and that will reflect just enough more of the sunshine away from the earth to help us out. Problem is there may be some side effects that we don't want. And I think that's what your modeling has been looking at. So give us a précis of what you have been up to.
Yeah, thanks for that introduction. I guess on the flip side of what Trish does, which is all like observationally based with ships out in the real world, I'm completely in computer model land. So these are all hypothetical simulations of what the Earth could look like if we did some sort of marine cloud brightening intervention. And my work so far has focused mostly on regional applications of marine cloud brightening. So marine cloud brightening over very particular parts of the ocean. In this case, off the coast of California is one location we're testing this in the model, and another location is kind of over the Aleutian Islands in the mid-latitude North Pacific.
Did you say Aleutian?
Aleutian Islands, yeah, so like kind of near Alaska. Those are the two regions that we test this hypothetical marine cloud brightening.
So it's all hypothetical. You don't actually spray a single thing, right?
We're not spraying a single thing. We in the Earth system model assume that, you know, if we were to do marine cloud brightening one of these days, you could spray these particles into the clouds and it would be able to brighten them. So we skip all those early steps and we just assume that you have brightened the cloud. What are the large scale climate responses of doing that? So this is all relying on the technology working one day and being able to achieve the right size particle to actually brighten the clouds. But sort of the angle my research takes is if we were able to achieve that, what would the effects be? Would this be something we would even want to do? Would you get the desired climate effects? And so far, the first, you know, my first chapter in my dissertation is showing that you are able to achieve kind of a cooling effect over our target region, which is the Western United States, under present day conditions. But if you do the same intervention under sort of a future scenario, mid-century warming, like in 2050, the same intervention is no longer effective. And so that's kind
Okay,
of
now, okay, now you've put a lot of things into one sentence.
yeah.
If you could do this, what you're basically saying it would right now it would do some good things.
Mhm.
But later on, it might actually be counterproductive. Now,
That's
what
correct.
are the good things that you would find happening now? And it would be over the Western United States that there
Yeah.
would be these effects.
Yeah, so the intervention was designed to try and reduce summer extreme heat over the Western United States. That was kind of the goal of this regional marine cloud brightening experiment. And so when you do marine cloud brightening under these present day conditions, so like today's conditions, for example, you are able to get some cooling in the summer when, you know, temperature would normally be pretty high and severe, cause heat stress, all sorts of things like that. So that's what we're calling success in this case, a reduction in extreme temperatures.
Now, just a minute, because my understanding was that when you do this, you always do it over water. You never do marine cloud brightening over land. That's the word marine. That's why we use it. But that you're trying to cool the water under the clouds, not the land. Now, you said that the effect would be to cool the land in the U.S. Why? Is that what people really intended to do when they? I never heard anybody say they were trying to cool the land. They're just trying to cool the ocean.
Yeah, so when you do marine cloud brightening, which is correct, like you said, always over the ocean, just because you cause cooling in one spot doesn't mean it stays in that one spot over the ocean. So because, you know, the atmosphere and the ocean are always moving, like we get currents, we get winds, temperatures are always moving from land to ocean, ocean to land, depending on what the temperatures are. Just because we cool locally over the ocean doesn't mean it doesn't transfer over to land. So that's what we're seeing in this modeling case is, you know, when you cool over the ocean, those temperature responses are communicated to places over land through the dynamics of the climate system. So originally marine cloud brightening was proposed to cool just over, you know, the ocean. It was to cause global temperature reductions, but this regional approach is, you know, could we see particular cooling over areas over land if you do the right brightening over certain ocean locations. And that's through these, you know, pathways in the climate system.
So you're looking at a period of time. If you spray some clouds over the Aleutian, it's going to take how long for it to get over land? And by the way, where would those clouds go over land? Over Canada? Over where would you see this the effect on land? And how long would it take for the clouds to get there?
Yeah. So it's not necessarily that the clouds themselves are moving over land, but that the cooled water, ocean temperatures, and air temperatures that you've caused underneath the clouds are moving. And, you know, the natural wind system in the North Pacific is to move air from Alaska down the coast of the Pacific Northwest all the way down to California before it connects back to the equatorial trade winds. And so if you rely on that natural wind system, then you're able to move those cold temperatures we've created in Alaska all the way down the coast of California. Yeah, and that's on the order of like a year in the simulation, but it happens, you know, pretty fast.
Okay, now you say that would be a nice thing to do if we could do it today, but we can't do it now. And it's more likely to, if it ever happens, be decades from now, at least. And by then, it wouldn't help. It would be counterproductive, right?
That's what we're seeing. Yeah, that's what we're seeing in these simulations.
What's the explanation for why you think that would be the case?
Yeah, it's there's probably a lot of reasons, and we've kind of only discussed one in my paper so far, which is that the ocean currents in a warmer climate are very different than they are now. So currently we have a big ocean system that's able to move, temperatures from the poles to the equator. It's called the Atlantic Meridional Overturning Circulation. It's basically a pathway that our ocean moves heat and salt all the way throughout the world to kind of smooth out any temperature differences across the world. So that's how we regulate our thermostat basically of the planet now. This system of ocean circulation is supposed to slow down in the future when we have a warmer world. And so when you do marine cloud brightening in this warmer world, you're able to make that circulation spin back up again. And it's a little bit complicated to explain why you see the warming happening in Europe or over the Atlantic as opposed to just cooling over the Pacific. But basically, the gist is it's easier to perturb or spin back up this ocean circulation in the future. So if that was all very complicated, the thing you need to take away is that the base climate state is different under a warmer world in 2050 compared to what it is now. And so when you do the same intervention, you're acting on a different world essentially in the future. And this different world is sensitive in a way that makes it warm in certain places as opposed to cool everywhere.
Okay, now I'm going to be quiet, and I think probably Patricia has some thoughts about what you've said and maybe some questions. And I know that Robert does too, because I heard him asking your conversation yesterday. Patricia, is all of this new to you, or do you what would you want to question Jessica about from what she's reported so far?
Yeah. Hi, Jessica. It's good to see
Hi.
you again.
Yeah, good to see you too.
Yeah, no, I didn't realize, I guess I hadn't thought about the fact that you have to take into account that the climate is going to be different in 2050 than it is now. And so how is the system going to respond? So that's interesting to me. I guess the question I have for you, since you're much more familiar with this changing system, is if you think this is worth even trying at this point. I mean, or 50 years from now, or, you know what I mean?
Yeah, the results from this study might suggest that maybe we shouldn't go down this path. It becomes ineffective in a warmer world. But I think the bigger takeaway is that, when we research marine cloud brightening under current conditions, that may not be the full story. So we may find that, when we develop the technology and our design for where we're doing it today, that may not hold when we, fast forward 20, 30 years and actually need to deploy it. So we need to understand how this technology is going to respond under a variety of climate conditions and a variety of designs, because we're testing it in one spot, two spots in the Pacific, but it might happen in completely different parts of the world too, and kick off different climate responses that we have no idea what they are because we haven't tested them yet.
Right.
So I think it's still worth researching, but
Yeah.
to explore a wider range of strategies than we have.
So, and you also typically hear these model studies or proposals for real world studies being in the stratocumulus along the coast, the western coast of continents. And I'm not really familiar with what kinds of clouds are over the Aleutian Islands. So it also is effective there?
There are also low clouds if you look at the satellite images, which is what we used to inform where we were going to do this sort of intervention. So there are low clouds. I'm not sure if you would classify them necessarily as stratocumulus clouds, but I think the concern often with mid-latitude clouds is that they're in these storm track areas. So they're going to get moved around and broken up way faster than we see in, these expansive stratocumulus cloud decks, like in the subtropics off California.
Hold on, I'm not sure I'm hearing you completely. The Aleutian clouds are going to get broken up earlier than other clouds. Is that what you said?
Just that we typically get more weather and storm systems that come through in mid latitudes as opposed to the subtropical latitudes. So in shorter daily timescales, these clouds might get broken up or rained out faster in these mid-latitude regions than we would get in the subtropics, which is why people have typically thought, we're going to do marine cloud brightening in these subtropical cloud decks in the past. But when we see these satellite images with lots of low clouds in the mid-latitudes, maybe it could be a viable option, even with these storm systems.
So how much of a temperature decrease do you see?
Yeah, that's a good question. Kind of on a global scale or like a regional scale?
Either.
Either, yeah. Okay. Well, let's see. I can pull some stuff up. Kind of on a global scale, we're talking on the order of like a 0.2, 0.3 degrees C decrease in temperature. I think, over the target region, it might be a little bit higher, like around the order of one degree or so. But it's...
Now, let me make sure. If you do this locally, and you're not talking about spraying the whole section of the world, but just a local area, you're going to have a global response of 0.2 or 3 degrees, or what?
Yes.
Did I understand that?
Yes.
Even if you do something local, it's going to have a significant global effect.
Yes. And that's kind of one of the big takeaways of this work is that, something that's designed as a regional study can't really be confined because the whole climate system is connected. So just because you do something small in one region of the world doesn't mean it stays in that region. It affects the whole world.
I might jump in, Meta. I think what Jessica's paper showed was that if you do restrict marine cloud brightening to just a local region, then it wouldn't be sufficient to bring about the global cooling that's needed, and what that suggests to me is that we really need to be thinking about the global governance issues that surrounds this topic, because it will be really important that if studies go ahead, for example, in the North Pacific, then there are also studies in the Atlantic, the Indian Ocean, the Southern Ocean, the South Pacific as well, because it will be necessary to combine the effects on a global level and understand it globally, and that will need all of the nations of the world to agree to implement it. Now, it may be possible for one nation to go ahead on a local basis, and Australia's already done that with the tests on the Great Barrier Reef to stop the bleaching of coral on the reef. That's just at a very preliminary stage, and it's not really in a location where these connections, they're known as teleconnections between different climate regions, are as significant as the sort of scale that Jessica's talking about in the North Pacific. But still, it's just essential that the world climate be understood on a global basis. We have to think globally in this new era that we're in with global climate change, global warming, and global warming can only be addressed by global cooling, not by local cooling. I think it's like we can't sort of cut ourselves off and go into a bunker and think that climate change won't affect us. Climate change will affect everyone everywhere, and so we need to work together to address it.
I want to know whether this is good news or bad news. I'm not sure it's something that I had recognized. In fact, I know I hadn't thought about it before. But I'm not sure I really understand all of the implications of what Jessica has said, that if you do something that's local, the effects are going to be global anyway. Well, that's pretty vague. That means you really don't know what the effects are going to be. It could be, other countries. Can you predict if you do this locally? Can you find that there's a particular other locality that's going to be specifically affected or with a high probability? If we do it in the Aleutians, is it going to be Nome, Alaska that feels the effect? Is it going to be Chicago, or where are they going to notice the difference? If you just say it's global, it might mean it's just too diffuse. The effects are too diffuse to even decide where the effects are. So tell me what you found about how you can predict where the effects are going to be.
Yeah. So I guess probably the most interesting case that we ran was the one under mid-century warming. So fast forward to 2050. You do marine cloud brightening near Alaska, you get cooling locally over the ocean, but then you get warming over North America and you get warming over Europe. And so that's kind of a surprising finding. And I think you asked, what can we predict with these local interventions? And I guess I'm going to say that these are not very predictable. This was an unexpected finding that we were causing these patterns of warming. And I don't think you can predict what these far-reaching teleconnected effects are going to be until you actually simulate, what the local cloud cooling is going to be under these different climate conditions. So that's the challenge, is that it's hard to predict. We don't know what the far-reaching responses are because these aren't things that normally happen in the climate system.
Okay, Patricia, please, I'm sure that your own research has some connection to what she's reporting. Does this surprise you, what she said, and how does it relate to what you think you already know?
No, it doesn't surprise me that there are these so-called teleconnections, and that if you're making the clouds brighter, which means there's a smaller number of particles, and so you're losing the possibility for them to drizzle or to precipitate, then that is going to have effects downwind on land areas that are relying on that precipitation. So I think there's all kinds of implications. It's not just temperature. I think it's also people's ability to water crops, and that in areas that are probably already having droughts. So yeah, and I think that Jess is completely right. A big problem is it's so hard to be able to model, especially in a climate that we don't quite know what it is yet. What all of the effects will be downwind in other parts of the globe than where you're actually doing the cloud seeding.
Robert, help
Yes,
me.
well,
I don't know what to make of this.
Well, what that illustrates is just partly, as I said previously, that you can't just isolate one part of the world from another part. So, like, if there's going to be, if we said we're just going to cool the Pacific and we're not going to do anything in the Atlantic, then it's not surprising that we'd see the Atlantic warming up. And so maybe that Atlantic warming could be counteracted by also deploying marine cloud brightening in the Atlantic and perhaps in other locations. And with the rise of computing power for modeling and also artificial intelligence, it's possible to start thinking about, okay, if we refined the location and the amount and the timing of MCB deployment, then we could really optimize the overall cooling impacts. And there's also a really big learning by doing aspect of it, that it's only when we do field tests that we will and then start to gradually scale up those field tests that we will validate the results of the models. So it's likely a lot of the research suggests that the benefits really far outweigh the risks. And this has been one of the big debates, that there are a lot of people who are worried about the risks of solar geoengineering technologies. But then when scientists have looked at those issues, the scientific argument is that the benefits are so massive in terms of avoiding the risks of global warming and climate change, that it's definitely worth proceeding with research and with field tests, and having a very strong governance of the tests so that it's coordinated and properly measured and monitored and verified. And then the argument then is, can that bring benefits that we wouldn't be able to get just by really rapidly cutting our emissions? And that becomes a very complex political argument, because it seems like it's true that we can't, that just doing marine cloud brightening wouldn't be a substitute for cutting our emissions. But it's equally true that the converse, that just cutting our emissions can't substitute for the benefits that we need from marine cloud brightening, because we've seen a collapse of planetary albedo in the last few decades, like the melting of ice and snow, and there's also been a loss of cloud cover and also a loss of aerosols. And so all of those, we've seen the darkening of the world, and that's something that can only be remedied by rebrightening the world. Like we can't, and so we really need to look very seriously at the politics of it, because there's very strong political opposition to all of this work proceeding, and so recognizing that there's a moral imperative to protect the earth because of the impacts. So, like, I think extreme weather is the one that has probably been an impetus for Jessica's work, because just seeing the heat waves in the Western USA has caused a lot of people to say, well, what could we just do some local cooling that would slow down these heat waves? And the answer coming out of Jessica's work is, well, not really. If we just do the local work, then eventually it's going to be overwhelmed by the global effects. So the local work needs to be coordinated in a governance arrangement with similar activities in other parts of the world.
Okay, well, now what I'm taking from the early part of what Jessica was saying was basically, I think Jessica's saying, just don't even do it. It's just too dangerous. You don't know what you're going to have as a result. And especially, you're probably going to have bad effects if you wait 20, 30 years before you do it. And by then the world's going to be so different that it's not going to work. My inference from that would be, oh, that means we'd better hurry up and do it tomorrow. Now, because at least we can begin to learn from the actual on the ground or over the water experience. We can start actually testing and practicing this thing on a small scale. I believe that you do learn by doing. I believe that you learn but you don't. You don't go jump in the pool without dipping your toe in first to make sure what you're going to get. So you do it a little bit. You put your toe and then your foot and maybe a whole leg in, and gradually decide whether or not you're having bad effects. And that's what I would start doing. Now, right, if we started really to rush it, try to get marine cloud brightening going on some small scale within the next 3 or 4 years, it means that we're not going to do it very well. For one thing, the sprays, the nozzles are not good enough. So we're pretty sure that the size of the of the aerosols are not going to be the right size. But you can start to work on looking at various effects by actually practicing. And in fact, they have a couple of times now recently. There was one in Alameda, and then, as you mentioned, the one in off the Great Barrier Reef where they are actually spraying. So I guess that I've thrown us into an area of great controversy because there are many people, probably the great majority of people would say that the real implication of Jessica's work is that we shouldn't even try it at all. Whereas I think the implication is we better do it as fast as possible. And so I just like to create trouble when I can. What do you people feel about what I've said and what Robert has said?
Well, I think we need to step back here and see what has actually been done. There was a study in Alameda that was only creating the spray droplets, so that did not measure any impacts on clouds, and it was actually shut down by the city of Alameda because I don't know the ins and outs of it, but they didn't feel like they had the proper permissions to go ahead and do this. So
yeah,
Robbie,
but they within a few days they had the scientists check it out thoroughly and give them a go ahead, so they did go ahead and do it.
oh, I didn't realize they had restarted
Yeah,
it back up.
Yeah.
No, they haven't.
The effect on the climate in the Bay Area would have been, infinitesimal compared to the amount of spray that comes in, every day. So there was nothing to worry about, and very quickly people were assured that there was no danger whatsoever.
Okay,
So,
my point, that's not my point of whether it was going to be dangerous or not. It's just the fact that did. I'm also not sure if it made the right size particles. I assume it did because it had designed the nozzles just to do that. But my point is that that's a very small scale, and it wasn't looking at the impacts on clouds. It was just looking to see if the right particles could be emitted in the right amounts. That's my understanding. And also the Great Barrier Reef one is also quite small scale. So I'm just trying to get us to be more realistic. There's no way to spin this up and start doing it now. We don't even know how you would create enough spray over enough of the ocean to actually get the aerosols up into the clouds. So there's a lot to be learned. I agree that these small scale studies are probably a good idea. In fact, in our work here at NOAA, we're flying drones with miniaturized instruments on them to look at aerosols and clouds and their interactions. And it's not that NOAA is promoting marine cloud brightening at all. It's more having the role of the monitoring and verification of what the impacts are. So that's important to have, like Robbie said, it's important to have that component if you're going to start doing these small scale experiments.
okay. I don't know I'm not going to call on people. Who wants to speak? This is a free for all. You're allowed to interrupt each other. All right, Jessica, I will call on you.
All right. I guess I think when this paper came out, a lot of the media's hype was about like how we're going to cause heat waves. It's going to be terrible. Like maybe we shouldn't do marine cloud brightening at all. And I think that's kind of what you were speaking to earlier, is kind of the devil's advocate side. I also don't think I would be cautious to say we should go out and start doing marine cloud brightening, today, because I don't think that we're in a state, like Trish was saying, to do this right now, realistically, with the technology we have. I think I am an advocate for doing more research and more small scale experiments on this. I think that's what really this research is showing, is that we need to go full speed ahead on the research, but not necessarily on full scale deployment yet. So that's what I would say my position is currently.
Robbie?
Well, that's exactly right. And because we're not in a position to do deployment because the technology for generating the submicron particles hasn't yet been established. There are methods to generate the particles, but they're very expensive, using a lot of electricity, and so there hasn't yet been developed a cost-effective way to produce the spray at the scale that's needed some people think that's impossible. So the technological barriers to deployment remain considerable, and there are a number of teams around the world who are working on that generation issues. So first you've got generation, and then you've got distribution, and so there's a whole scientific engineering agenda around both the generation and distribution of particles. Like Professor Stephen Salter had quite a visionary idea of semi-autonomous vessels that would move to the areas of highest need for marine cloud brightening. But that's a long way down the track, and there's no money available for that sort of research, or very little anyway. And there's some work happening in the UK, also on the west coast. Armand Neugemans is a leading scientist engineer on the generation questions. But then the other thing is the governance barriers, and I think that the Alameda study is a really strong illustration of the barriers to governance, and because the mayor said that they didn't want to be pioneers in unproven technologies, and so that's something that shows that the general public have very little information about the need for direct climate cooling, and so there needs to be a much more public debate and awareness raising about the benefits of these sorts of issues, and so I think it needs to be linked to some of the big impacts of climate change, because Jessica's mentioned the AMOC, the Atlantic Meridional Overturning Circulation, and that's identified as one of the big planetary tipping points that could cause a climate catastrophe if it's slowed down too much. And so if marine cloud brightening is able to protect the AMOC and stop it from slowing down, then that would be a really major benefit. So,
well, now hold it, because that sounds, I haven't heard anybody say that that's a possibility, or maybe I wasn't listening carefully. You mean that somebody is saying that marine cloud brightening could prevent the slowing and the failure of the AMOC? I wish to tell people what the AMOC is first. And
so it's the Gulf Stream, that the warm water that flows from the Caribbean up to the Arctic is one of the main components of the AMOC, and most of that water, as Jessica could probably explain better, when it gets up into the North Atlantic, it gets cold and salty, and so it falls to the bottom, and then when it gets to the bottom, it flows all the way back down to Antarctica. So you've got this really big circulation, north-south circulation in the world ocean, that is one of the primary patterns of the global climate, and it's slowed down by about 15% in the last decades, and it has stopped in the past, and so and that's if it did stop, then it would plunge Europe into extremely cold temperatures, which would ruin agriculture, and it would be just a great catastrophe. And so the idea that we need to protect the AMOC and stop it from slowing down, and that's one of the factors that's causing the slowdown of the AMOC is that there's more fresh water coming out of the glaciers from Greenland and so on. And so if marine cloud brightening was able to refreeze the Arctic by cooling the currents that are flowing into the Arctic and also directly, then that would help to protect the AMOC.
Mhm.
And so so anyway, there's a bunch of tipping points, like Arctic freezing and Arctic melting and Greenland, and the ocean currents circulations getting mixed up, that could be mitigated by marine cloud brightening. And similarly, sea level rise is just a major risk. You know, if we got a meter or two of sea level rise this century, that would be quite an economic and social catastrophe. And so, if we can slow down the melting of Greenland and Antarctica, then we can slow down sea level rise and buy some time for the slower work of emission reduction.
Okay, now that would involve a local intervention, marine cloud brightening specifically in the Arctic, right?
Well, no, it's all teleconnected. It's global. So it may be that marine cloud brightening closer to the equator would have more effect on the temperature in the Arctic than marine cloud brightening in the Arctic itself, because like you can only do it in the summer in the Arctic, and globally the Arctic is just a really small proportion of the planetary surface, and it doesn't get so much sunlight. So if you do it in a bigger area where there's more sunlight coming in, then that will connect to the temperatures at the poles.
Well, do you mean to say there's a certain spot out toward Hawaii someplace that if you do marine cloud brightening right there, then there's a certain spot near the North Pole that will be affected and cooled? I don't think so.
It's about bigger regions. So, like as Jessica was explaining, like there's a whole bank of stratocumulus clouds that sit off the coast of California, and if that whole bank of clouds was brightened, then that would have a global effect. Similarly, the Aleutian clouds, if they were brightened, then that has a global effect.
I mean, I think that if you're going to try to refreeze the Arctic Ocean, which is certainly a tall order, probably unachievable, but the only way to do it would be a very specific action. You can't go around spraying the whole world and hope that that may do it for the Arctic. I think it has to be a local application for a local effect, and that's what I'm hearing you say won't work.
Yeah, it's also the currents, the ocean currents that flow through the Bering Strait and the Gulf Stream have a really big impact on the Arctic. And so if you cool down those ocean currents, then that will have an impact where the water is flowing. It's, as Jessica was saying, if you cool down around the North Pacific, then the air and water under those clouds will then flow into another location.
Oh boy! Well, we clearly need more. Patricia, how do you intend to do, or know of anybody who intends to do some specific research project that would have any bearing on illuminating these questions or giving us an answer to them?
I guess the only people I'm aware of that are doing this pretty aggressively is the University of Washington group that did the Alameda study.
Right.
But it's also, so it's got to be a mixture of, you know, designing the nozzles, seeing where the aerosol goes, if you can get them up to the clouds. So focusing on some local area like we've been talking about. But then you also need the modeling piece of the type of work that Jessica's doing. So yeah, I don't think it's a very widespread application right now, trying to do any of these local experiments. And that's part of it is lack of technology or need for the development of the technology. And part of it is the governance issue that we've been talking about, getting the permission to do it.
Oh, well, that's I think also comes out of public opinion, because people have been not very well informed about this, which is why we have these meetings.
Yes.
But you know, I want some hope I want some basis for figuring out next steps and what needs to be done. Well, let's say your project is to do what Robert has suggested. We've got to protect the Arctic ice by working on the flow of water that affects the ice, so it goes into the area. So who's doing anything that's going to help solve that as a problem? I see it as a project, as something that actually urgently needs attention just to save the world. So who's working on anything that's going to help solve that?
There's some
I'm-
good work in the UK. So the Advanced Research and Invention Agency is developing a program for climate and weather modification, and they are looking at local modification, mainly with a view to reducing the impacts of storms on the UK. Like if they can cool down the water in the Atlantic, then they're looking at those local impacts. But it's interesting to see how Jessica's work suggests that while that might be a really good starting point, it will then need to be integrated at a global level. And there's also work happening in Israel. So there's various activities around the world.
Well, we're nowhere near having an international agreement to anything, frankly, that makes any difference. But there must be individual projects that are less ambitious, but that would be building blocks or stepping stones or could help toward moving us forward by solving some more specific problems. And that's what I want to think about. Where do we go next to look for somebody who's got some way of working toward a solution, a practical answer? Because Jessica, you just threw cold water on a whole bunch of stuff. You know that.
Yep, it was a shocking finding. And I guess, this area of research is not particularly well funded. So a good starting point would be getting more funding support for people to go out and do these sorts of,
So what?
experiments.
Now, if I gave you $20 million tomorrow, what would your project be that would help move us?
Well, I think like everything we've been talking about, we need efforts from the global climate modeling community. We need efforts from the observationalist community. Are these clouds going to be able to be brightened? What are the weather conditions in these places?
I like to start with where there's a problem. Where right now is the most interesting problem that if you could solve that, you would have made real advance. If you don't work on trying to solve a particular problem, you just go around looking in the dark. So what is the most interesting problem that could be answered if you had the money?
Well, I'll comment on that, and I would say it's the relationship between solar geoengineering and tipping points, because the tipping point community, led by Professor Timothy Lenton at Exeter University in the UK, are totally opposed to research on solar geoengineering because they see it as too dangerous. And so
They see it as what?
They see it as too dangerous. And so it's very interesting for us in the geoengineering advocacy community that we are really completely at the margins of the scientific debate. And I'm not saying that Jessica and Trish are advocates. Like there's a community out there who look at it in political terms primarily and just say, there's not much prospect of actually cooling the world by cutting our emissions, and so it's urgent that we actually move towards deployment. And James Hansen, in his Global Warming in the Pipeline major publication last year, said that marine cloud brightening is the most innocuous way to make a start. So there is a level of support for marine cloud brightening, but there's also extremely strong opposition that currently has the weight of numbers. So the IPCC is totally opposed to geoengineering. They did not mention it at all in their last summary for policymakers, reflecting the intensity of the opposition. And so I would say it's this global governance and advocacy issue around, is this something that's needed to address tipping points? That's a security question that is needed to be answered, and that's going to really determine the likelihood of any field tests, because under the current political prevailing circumstances, the opposition to field tests is so strong that it's likely that there'll be delays in similar to what's happened in Alameda.
Patricia.
I'm sorry, Matt, I have to run to another meeting now. Thank you very much for having me. It was a very good conversation.
Thank you very much. And if you think of another project that you think would be more promising than where we are now and getting us out of being stuck, let me know.
Okay, I will. Thank you.
Okay, thank you. Bye. And Jessica, seriously, give me a quick design for if you had the money to do your next project, and it's not just to make your CV look good, please. I don't care about people who think about their CVs. I want you to help us solve global warming the fastest and the best way that we could possibly do it. And I want you to design, in 30 words or less, a research project that I will personally fund from my piggy bank, and you'll get a check tomorrow to start to work on it. What will you do with all this big money of mine?
That's a really tough question to think about in 30 words or less. I guess
this is your life, lady. I'm not kidding. If we don't take our lives seriously, shame on us. Take it seriously. This is really, you're in a position to do something important. Now do it. I'd get mad at you if you don't. Seriously. Yeah.
Well, I guess something I'm really interested about right now is how we can use marine cloud brightening to target things like El Nino. You're familiar with El Nino. Mm-hmm. It causes warming during certain times of year, and then it switches to La Nina during other years. It's this big oscillation in the climate system. And it gets worse when we have global warming on top of El Nino events. It causes some of the warmest years on record, right? We just had probably one of the warmest years on record this year.
And you think that marine cloud brightening might be able to address that?
I think so. And I think if I had more money to get to the bottom of that question, I would.
I'll go see how much I've got in the piggy bank right now. Thank you so much. It's been fascinating, and it's only the start of a very big project. We got to save the world. All right. Thank you all, and see you another time. I really appreciate this. Okay. Bye.
Thank you, Meta. Goodbye.
Bye.
Thanks, Jessica.
Project Save the World produces these forums. This is episode number 621. You can find all the forums on our website. Just go to tosavetheworld.ca and look at the scroll window on the home page. You can scroll around until you find a topic that interests you, and then click, and you can watch the forum right there. Project Save the World also produces a short course for people who want to become leaders in the movement to repair the climate. This course is available free of charge on the online learning platform Udemy. It consists of 5 short lessons about the use of soil amendments as a way of removing carbon from the atmosphere and sequestering it in the earth. thereby improving agriculture and increasing the world's food production while reducing the need for synthetic fertilizers. The course is entitled Become a Climate Change Influencer, and you can learn more about it at this link, www.become-course/climate-change-influencer. Finally, Project Save the World also produces a quarterly online publication, Peace Magazine, which now serves as a free of charge newsletter to help mobilize knowledge about 6 global threats to humankind. We gladly email the magazine as a PDF or link to any interested organization in the world that works to prevent a global catastrophe involving war and weapons, global warming, famine, pandemics, radioactive contamination, or cyber risks. Just email us at office@peacemagazine.org and we'll add your group's email address without charge to our list. For individual subscriptions at $20 Canadian per year, go to pressreader.com on your browser and search for Peace Magazine.